So shapes of distribution is today's lesson. What this is looking at is how is data displayed in different types of graphs and how is it distributed. So we look at symmetric and skewed distributions, just kind of like we did with the box and whisker plot. But here we're going to look at it with histograms and the box and whisker plots and everything else. And we're going to be able to describe the measure of center and data. We're going to use standard deviation and mean and the range and IQR and your median. So what's important in this first spot here is if you have data that is considered to be symmetric. So that's right here. So if you're looking at a histogram, it has what we call a bell curve. So it kind of goes up and then comes back down. And all the data is pretty symmetric on either side. When you want to describe the data, you're going to use your mean to describe your measure of center, and you're going to use your standard deviation to describe your spread of the data. Since your mean and your median are about the same, the mean is always the best to describe your measure of center. So when you have symmetric data, you always want to use your mean and your standard deviation. If you look and your data is skewed, so this one is considered skewed left because the majority of your data is over here on the right, but then it's getting pulled down to the left side here. This one is considered skewed right because the majority of the data is here, but then it's coming in whipping down this way towards the right. It's kind of like with the box and whisker plots when you'd have that long tail on this side or that long tail on this side. It describes which way that data is being skewed. So if your data is skewed, the measure of center that you want to use is your median because that mean of your skewed data, the mean is going to be affected. Your median is what is less affected. And then you want to use your range and IQR to describe the spread of the data, not your standard deviation. You're going to use that range and IQR because think about those. Those are basically your median values. Not necessarily range, but the IQR uses your median values. So it's not going to be as skewed. The data is going to be more representative of it. So choosing the appropriate measure. Okay. I'm using my key. Which measure of central tendency best describes or best represents the data? Explain your reasoning. So in this one here, you can see that your data here kind of comes up and then goes down and is pulled to the right. So this is considered skewed data. So when you go back up to the top, it says which measure of central tendency best represents it. It would be the median because the data is skewed right. In this next one, you have that nice little bell curve going on there. So this is considered symmetric. So it would be the mean that would best represent the data. So if you want to pause the video, you can write this down in there. So what this means here, I've used this in class before, it means therefore, it says distribution is skewed right, therefore use the mean. Distribution is symmetric, therefore use your, I said the wrong word here, median. Therefore use your mean in this one. So this next piece says, display the data in a histogram. Describe the shape of the distribution. Which measure of central tendency and dispersion best represents the data? So when you start to create your histogram, this one here already has your range of values set up for you and the frequency in which they occur. So number of tickets sold, between 1 and 8 tickets sold, it happened 5 times. 9 to 16, it happened 9 times, so on and so forth. So when you create your histogram, what you're going to do is you're going to create that basically like a bar graph. And then down here is the range of values. Okay, so this is going to be a range. So we're going to actually label it as number of tickets sold. Okay, so number of tickets sold. Your frequency is going to go on your y-axis. So for this one, you're going from a low number of 5 to a high number of 25. My suggestion would be to count by fives. So you always start at 0, and then you'll go 5, 10, 15, 20, 25. And then down here, it's going to be 1 to 8, and then you'll have 9 to 16, and then you'll have 17 to 24. So and so on and so forth. When you do this, all of your bars always touch, and they are all the same width. So 1 to 8 is a frequency of 5. So what I do is I go here, and I draw that box. 9 to 16 has a frequency of 9. So they're supposed to be connecting. They're connecting, and that comes about up to there, and they need to be about the same width. 17 to 24 is 16, so they're connecting, and they come up. Whoops, that's a little too high. To be about the same width as well on that one. So on and so forth. So please pause the video, create your histogram. Okay, so when I created mine in my notes, I had actually counted by 2s. You can count by 5s. You're still going to see that same distribution. So when you're looking at this, so we displayed our data in the histogram. It says to describe the shape of the distribution. Whenever it says that, it wants to know, all right, how is it distributed? Is it symmetric or is it skewed? This has that beautiful kind of bell curve to it. It's not perfect, but it is pretty symmetric. So which measure of central tendency and dispersion best represents it? When you're doing that, the one that's best going to represent it is, since it's symmetric, use your mean and standard deviation to describe the spread of the data. So for this next one, you can see your frequencies go from about 7 to 34. So this one I definitely would count by 5s. And you are going to put the number of pounds, the range values on the x-axis. You're going to put your frequency on your y-axis, and you're going to create. Histograms are very time consuming. So pause the video again and create that. When finished, this is what it's going to look like. So you can see in this one, that does not have that nice bell curve. It kind of goes up, and the data is here, and then it kind of jumps right back down. So this one is considered skewed left. Therefore, we're going to use your median and your range in IQR to describe the spread of the data, since it is skewed. The next piece now, let me go to here. I actually have to go backwards. It was all upside down. So this next piece now talks about a police officer measures the speeds in miles per hour of 30 motorists. The results are shown in the table below. Display the data in a histogram using 6 intervals starting with 31 to 35. So what this is going to do is they want you to create these 6 intervals. So the first interval they say they want you to use is 31 to 35. So then after 31 to 35, okay, you're going to have 36 to 40. So it's like an interval of 5, starts at 31 to 35. So you'll have 36 to 40, 41 to 45, and then 46 to 50, 51 to 55, and then 56 to 60. So as you go through, you can see how I have these tick marks going here. You can tally up how many fell into each category. Once you're done that, create your histogram, putting these on your x-axis and your frequency on your y-axis. So pause the video and complete your histogram. So here we can see that the data again is going to be skewed left. Okay, so it's getting pulled to the left there. It's asking you which measure of central tendency and dispersion best represents it. Well, since it is skewed left, use your median to describe the center and your range and IQR to describe the dispersion. The speed limit is 45 miles per hour. How would you interpret the results? So again, interpretation, there is no one exact right answer, but I just said here, because the distribution was skewed left, most speeds were actually more than 45 miles per hour. So most people are going above the speed limit. So you can look at your distribution and you can describe that distribution by using a measure of central tendency and a measure of dispersion. If it is symmetric, use your mean and standard deviation. If it is skewed, whether it's skewed left or right, use your median for your measure of center and your range and IQR for your dispersion.